I'll be the last presenter. Yeah, you can go home. Yeah, but tomorrow's Monday, so I'll keep it short. I need to keep it short. I'm a master's student at UEA doing climate change, and I just finished my program. I'm going back next week, so this is a great opportunity to actually present a bit of my research. And it's kind of scientific, so please ask questions afterwards. Okay. So my topic today is about disruptive technology. And we all don't want to get disrupted. We all have our comfort zones, but today's technology is going to disturb you and how you live and the way you live and how you really relate to the systems that support what we have right now. For example, the Google Glass is a good example. And this, for the academic perspective, is what I did. It's such, I have never seen so many errors in one diagram before. Basically, I was looking at the niche where inventions become innovations, and then they align and they disrupt our social-technical regime. It's where we live, our comfort zone. This is a good example. Just in 40 years, we've come from 8-track to LP to cassette to CD to downloading music. And it goes into a cycle in waves, goes up and down, one phase out. And now if you want to play something from a cassette, but you need to play a cassette, you need to buy a cassette player. With that money, you can probably buy a couple of favorite songs from iTunes. And yeah, today I'll be looking at energy systems, which is very, very hard to change, but it has to change. And the site has to change, yeah. Yeah, the energy system is really hard to change because it's so fundamental. Electricity is invisible, and you never really think about where the energy comes from and what resources you use when you switch on that light. And this, I think, is from China. This shape. Yeah. And so I've always thought about, so what can really disturb the energy system we have right now? It completely fundamentally change it. And that was hydrogen. And hydrogen is the first element to the periodic table, which means it's the lightest and the most abundant in the world in the form of water. Hydrogen, 2 atoms, 1 atom of oxygen. It's a very strong chemical bond and stable. And this is an example of how we would use hydrogen in our energy system, or for example, like electricity and heat. So you have the hydrogen bond, H2O, and you split it with electricity. So you get hydrogen gas and oxygen. And then it's gas form. You compress it in a tank, and you use it when you want to use it. And then one of the biggest benefits right now is that you can adjust the balance of electricity supply and demand. So you always don't have to build these big nuclear power stations to meet the peak of demand, which is only 3 to 4 hours in midsummer. Yeah. So I hope I get this rolling, but my concept that I want to communicate to you today is about renewable hydrogen, and there's a clip that might play or not. Yeah. So you have water, and you split it. You skipped something. You have water, and then electricity comes, splits it into H2 and O. You release oxygen into the air, and hydrogen gas, you compress it into a tank, and then when you want electricity, you then get oxygen from the air, and while it gets that hydrogen oxygen chemically reacts, it releases electricity and heat, and because H2 and O bonds together again, it becomes water. So it's a very sustainable cycle of energy. And this is at the Tokyo Motor Show, and we always have high-tech stuff, and there's a little kid dreaming about hydrogen. But all of these benefits you have, for example, it can store energy, so it can be an emergency backup. It has clean air, it has no pollution, no carbon dioxide at the point of end use. And this is actually happening in the world. This is a concept image. Everything starts from concepts. This is in Brisbane, Australia, at Griffith University, where they have a 6-story building. You can run completely off-grid from solar panels, and it stores the energy that's not using during the day because you have natural lighting from the sun in hydrogen form. These concepts don't just stay as concept. They're actually, this one was completed in June this year, so they become reality. And it's very pretty. All glass, and with solar film outside the windows. Yes. This one is from Japan, in Saitama Prefecture, which is just above Tokyo. This concept was released in 2011, where it's a hydrogen station, so you use the hydrogen as a fuel to run cars. This is a fuel cell car, and you can actually buy it. Yes, and it's about $600 per lease in California. And in 1 year time, it becomes reality again. So I went here, and I even had the chance to drive it. It's very quiet because there are no running, moving parts. It's all a chemical reaction. That's the car. Honda, hello. Okay. And it's also big in UK because UK is an island and you have to import fossil fuels, which costs a lot of money. Energy security, you have to think about that. And London is very supportive of it because of the problem of air pollution. And here's a fixed bus route RV1 going through Covent Garden. And this one is from Taiwan. So fuel cell, this one is stuck into a scooter. This is the width of my hand. And these are the tanks that actually store the hydrogen. And made out of metal, magnesium. Yeah. And this concept is really interesting. It's like a vending machine where you pop in that cylinder and it stores hydrogen. And when it's done, it just automatically pops up. And when you want to refill your scooter, you just go there and take it out like a vending machine. It really looks like a vending machine. Yeah, and this is a scooter. So you stick those two canisters inside. And it runs about 80 kilometers with 30 miles per hour speed, which is just enough for a scooter, just fast enough for a scooter, and just enough of distance to get you around Taiwan, which is an island and it's small. Yeah. So that was really quick, 6-minute presentation, but I really think that change and what I've studied about transitions, that it all starts from really small actions and small concepts. So I think because everyone can draw a concept image like the one I just saw, that you should go home and think about what kind of change, disruptive change, I hope that you want to see and just start drawing. Thank you.